video, I wanted to talk about a little bit more of the conceptual ideas of what's happening behind the hood with Mirror. We're not going to go too deep into Mirror. It's very high level, more understanding how network communication happens and how you can take advantage of that inside your own projects. So the very first thing that we're going to talk about is the concept of a server and a client. So if I click play here and I have the debug window enabled, you'll see it has a couple of options immediately. It says start localhost plus client, start server only, or join localhost. And really this should just say start host or join host because it may not necessarily be localhost, but by default it is localhost. So what does that even mean? So how is it possible to start a server and a client together? Are they not the same thing? And the answer is they're different. You can think of it like this. So here is my local machine right here. And on my local machine, if I start with host and client, we see that there is a server running. So that's the host. And here is a client running. And so that is the concept of a server and a client. So when somebody else says join localhost, they're actually saying, hey, I want to initiate and have connections, have communication with the server. And let me actually make this a double arrow because there's a two-way communication happening there between the client and the server. And that same thing is happening here locally. And that actually makes it really nice coding-wise because when we use things like client RPCs and commands, whether or not the server is running here on my local machine, or if we take this server and we move it up here to be a dedicated server, the coding concept is exactly the same because it's still that server-client relationship. So I'm still going to initiate my connection with the server. The server is going to, initiate when the client connects up to the server, it's going to initiate those connections with the other machines. So whether or not I'm running the server on my same local machine, or I'm running it on a completely separate machine, like a computer that I have at my house, or an Azure instance, or a Google Cloud instance, or an AWS instance, the concept is the same. So let's also take a dive into, so how does the server communicate with my client, right? What do I need in order to do that? And in the concept of Mirror, in order to have a communication between your server and your client, you must have a local player. So in my network manager, I try to make that a little bit more obvious. So instead of a local player, normally in just the network manager provided by Mirror, they just call it player prefab. I actually changed that to be called connection prefab. So the connection prefab is super, super important. Basically, this is the hub where all the communication is going to be flowing to and from on your local client. So if we pull this back up here, so if we dive into this client right here, and it's going to be the same for all of these clients. If we dive into, look closer at the client, it's going to look like this. So this red arrow back and forth, that's the communication that's happening right here. That's this server to client communication. And when that server is communicating with my client, it's actually coming to my local player. So that local player is then basically passing that information on to objects that I have authority over. So there could be hundreds, if not thousands of objects inside my game, but there's only going to be a few that I have authority over. So when something changes on this object that I have authority over, it's sending it to my local client and sending it to my local player, and then forwarding that on to the server who's going to manipulate things and maybe respond back and then send it back to here. So you can see how important it would be if I just like killed this. you see basically all of this dies with the local player. So that's the difference between the connection prefab and the player prefab. So the player prefab is something that my player connection is going to have authority over. So if I click play here, and in fact, I don't want to spawn my player, so I'm setting auto spawn player to false. So you can see that as soon as I connect to the server is going to immediately generate a player connection prefab. That goes back to this, the local player is going to generate a local player on my client. So I'm going to go ahead and click start localhost and client, because that's going to generate the server, but then it's going to generate my client, which is my local player. So if I come over here to don't destroy unload, here we go. So it generates a random name for me, but here's my player connection. So if I was to generate, if I was to run this, in fact, let's do that. I'm going to build this and go ahead and run it, but not actually spawn my player, and you'll see it'll generate my player connection for me. Okay, so I got that running, so let's click start over here. And part of this, due to decompilation protection, I have to start my server on Unity. So when you're due to decompilation protection, if you're building a server build, you have to tick server build here, and that will allow this server logic to be built into your executable. Otherwise, you can only run it from Unity or a built server. So since this is actually built as a client, it doesn't have the server code built into it. So I'm going to go ahead and click localhost here, and we see that it generated that connection for me. And my net ID is it's all nines. This is something that I've put in there. By default, your connection ID is 0, 0 if you're the client that is also running that also has the server on your machine. So I'm going to go ahead and click join localhost. As soon as I do that, you'll see a new connection show up. So a new connection just showed up here, and you'll see that there's a couple of errors related to a few things that I need to fix, but you get the concept that the player connection is made. So when I spawn my character, it's going to populate this character controller, but this is really just only a concept that the player connection knows about. The player that you play around with is just something that you have authority over. It's not actually your local player. See that? Like it's not here. The player that you're playing around with is in here. So it's an authority object. So if we come look at that, so that's right here. This has authority objects. It's just one of the objects that my local player has authority over. So if I come over to here and I leave, I need to fix some of those errors. Okay. Oh, nope, never mind. It just took a little bit. That connection disappeared. And if I had any objects in here that this connection had authority over, those objects would be destroyed with this player connection object because of this concept right here. So you'll also see this in the code where it says, gets the network identity and it says is local player. So if I run the is local player on one of these objects right here, it's gonna come back false. So because you can only run it on the local player. That's the only place it's going to come back as true. But if I run has authority on this, it's going to come back as true, the same as it's going to come back on this as true. That's if my client has authority of this. So if I run this check right here on a different client's object, that'll come back false. But if I run it on my client's object, it'll come back as true. Hopefully that makes sense. So with that said, let's actually dive into a little bit more. And so how do we actually make, how do we communicate with the server? So Mirror provides a couple of ways. So one thing you need to understand is that Mirror is by default server authoritative. So that means clients basically communicate with the server, and the server is going to perform kind of the intensive logic, and then it's going to respond back to the clients with the results. And that's great to prevent cheating. So the clients can basically, for example, when they take damage, say, oh, I set my health to 0. But in reality, the server is saying, hey, you took damage and I'm setting your health to 80. And so it's going to respond back with the client and force the client to reset their health to 80. The same goes for on death and other situations like that. So the first thing that you do is if you want to have a client send information to the server, you have to use something called commands. So commands are something that the server is going to execute. So as you can see here, the server is the thing that's going to execute a command. So clients say, hey, server, I want you to run this command, and the server will just run that command. And then inside this logic, the server will not respond back to the clients. Basically, command just says, client is telling the server, hey, I want you to run this. And the server says, okay, and just runs it. Now, if you want the server to respond back to all of the clients, then you use something called a client RPC. So it's basically the exact opposite of a command. The server is the thing that initiates, says, hey, all clients, I want you to run this RPC. And the clients say, okay, and run all those RPCs. So you can kind of combine the command and the client RPC together. So inside the command that this executes, you can have the server call a client RPC that responds back to all the clients. So you can see how you can tie those back together. And if you want to only respond to have the server send an RPC to one client, that's called a target RPC. So instead of saying client RPC, you say target RPC. So sync vars are better than RPCs because they are persistent. So what do I mean when I say persistent? So the difference between commands and client RPCs is that if a client was to connect after an RPC has already been fired, that RPC will not fire on that client. So that's where sync vars come into play. So there's sync vars, sync lists, and sync dictionaries. Go ahead and review the mirror documentation on how you can properly use those. I'm going to quickly breeze over sync vars, but the concept of sync lists and sync dictionaries are the same as sync vars. So sync vars are server authoritative. So that means even if a client changes a sync var locally, it doesn't matter because it's going to synchronize with the server. The server has authority over sync variables. So if a variable was to change on the server, it's going to immediately communicate that with all the clients. But even more importantly, if that variable was to change and then a new client was to come in and connect, it would send those changes. It would send the current state of the sync variable to that client. And then you can combine that those sync variables with something that's called hooks. Hooks are are basically functions that can fire when that variable changes. So when a client is listening for a change on a sync variable and it receives a change from the server, it will immediately execute a hook. And you will notice, unlike commands and RPCs, hooks execute on everyone. Hooks are basically just watching for a variable to change on that local machine and execute a piece of code. So if we look back at client RPCs, you'll see that client RPCs only execute on clients, commands only execute on the server, but sync vars execute their hooks on everyone. So hopefully that gives you a better understanding of how you can take advantage of commands, client RPCs, target RPCs. So if we look at that really quickly, let's say I had a public void, and if you are making a command, you must always start your function with a capital C, lowercase md. That's just a mirror syntax that's required. I always like to put an underscore under it, but that's not required. And then the name of my function. So set health. And then integer value. So what I could say is on the server, I have a private int health equals 100. And then on the server, I say, okay, I want you to set my health value to what the client has told me to set it to. Now you'll notice this actually hasn't been specified as a command function. So in order to do that, I just say command. So now this function will only execute on the server. So if I was to have a client try to call this, you would get a warning message that would pop up. So then I could say, all right, let's make a public void RPC, because this is going to be a client RPC, and I'm going to call it just the same thing, set health int value. And then I want to say, hey, I want to set your health value to whatever the server tells me to set it to. And again, this is not a client RPC yet until I say client RPC and I specify as that. So here I've generated a client RPC function and a command function. Now I could say, hey, anytime the server sets its health value, I want you to communicate that back to the clients. So here I've just combined a command with a client RPC. So basically on my client component, I could simply call command set health 70. And that would communicate it to the server. It would set the server's health to 70 and communicate that change back to me as well as all other clients on the network. Now, like I said before, this does not communicate changes to newly connected clients. So let's look how we can make this persistent. And in order to do that, it's very, very simple. It's even easier in my opinion, but it's using a lot of the same concepts. So I could say protected int health is 100 again, but this time I want this variable to be async var. So now on my client, I can't just say health 80 because this will only be locally, right? I have to communicate this back to the server in order to have this get communicated back to all clients, even newly connected clients. So again, I could come back here and say command public void set health int value, set my health value to this new value, but I don't need to do an RPC because since this value, this command is changing a sync variable that lives on the server, because remember, commands only execute on the server, it's going to trigger a sync var, and anytime you change a value on a sync var, it communicates that to all clients on the network, even localhost clients. So it's going to communicate it to everybody, and even the power of this is that it's going to communicate it to even newly connected clients so that my health becomes persistent between client loads. So hopefully that helps you understand the how mirror works, how mirror networking works with your game, and how you can combine a server here. And that, you know, it helps you to understand, well, what happens if I want to have a single player only game? Well, that's fine. Just don't initiate a connection up with the server. And as soon as you're ready to have a multiplayer connection, initiate that connection, whether it's on your local machine or on a dedicated host. So like here, we could just make a build to run on the server. So if I come over here and say build settings, server build, and build, it's going to make this a server. And the reason that works is this little option right here says auto start server build. So as soon as, since this is a client, it's not automatically starting a server build. So I have to come in here and say start server only, and it's a server. And you see it didn't make my player connection because it's just a server. So that's what this is doing. This auto start server build as soon as the game launches, it immediately starts the server, which allows other clients to connect to the server. So hopefully that helps you. And let me know if you have any questions. Thanks. Bye.